This video is a review of our transformations unit. Alright, so we've got this diagram here. Which statements are true based on the diagram? Check all that apply. Points K, M, and N are collinear. Now this word collinear means that they are all on the same line. So if I have a line and I have points like this, alright, got these 3 points, A, B, and C. I could say that points A, B, and C are collinear. So you need to know that information. So, points K, M, and N, are they collinear? Well, here is K, here is M, and here is N. Is there a single line that could contain all 3 of these points at once? No. So that's a no. Let's see. Points J, K, and Q are collinear. Alright, J, K, and Q. Yes, they are collinear. In fact, you can see right here the line that contains all 3. So, yes. Alright, what's next? Point R is the intersection of line KN and line MQ. Alright, so here's K and here's N. So that means this is line KN. Okay. Now MQ. So here's point M and here's point Q. So this is line MQ. Whoa, I missed. It's a little bit better. There's line MQ. Where do those 2 lines intersect? They intersect right here at point N. So, point R is the intersection? No. It's not the intersection. It's N. Okay. Line JQ. Alright, here's J, here's Q. So this is line JQ, pardon my crookedness. Line KM. So here's K, here's M. So this is line KM. And MQ. Alright, here's M, here's Q. So this is line MQ. All intersect at point K. No. The first 2 lines intersect at point K, but that third one, the green line, goes nowhere near point K. So that's false. And then there is only one line that can be drawn through points L and P. Yeah, that's true. I don't even have to look at the picture for that. Okay, there's only one line through any 2 points. So they mentioned L and P. Yeah, there's only one line that can be drawn through here. And it's this line that goes like this. Alright, I missed a little bit. Let me see if I can fix it. Yeah, that line right there is the only line that can be drawn between L and P. Let's see, can I put some arrows on here? I don't have time for this. Yeah, that line I just drew, that's the only line that can go through L and P. There's no other line. So that's true. So that's it. So these 2 check marks are the only true statements. Alright, there you go. Alright, let's keep going. Which statements are true based on the diagram? Check all that apply. So same thing again. Plane S contains points B and E. Okay, so plane S is this plane right here. Alright, you look at it like a sheet of paper. So I can see that point B is on this plane. But point E is on this other plane. So no, they're not both on plane S. only point B was. Okay, so that was it for that. The line containing points A and B lies entirely in plane T. Okay, let's see, A and B. So here's point A and here's point B. Okay, so hopefully you can see that this is plane T, which is like this rectangle right here. Alright, hopefully you can see that points A and B are sitting on that plane. And so any line that's going to go through those points is also going to be sitting on that plane, like sitting on that table. So that's true. Alright, line V intersects lines X and Y at the same point. So we're talking about three lines, V, X, and Y. So let's find them. So here's line V, right there. Let's see, where's line X? See the X? Here's line X, right there. And that just leaves line Y. Well, here's line Y down here. Do those all three intersect at the same point? No. Alright, the blue line and the pink line intersect over here at point B. The pink line and the green line intersect over here at point A. They don't all three meet at the same point. If they did, it would be something that looked more like this. Here's what it would look like if they all three intersected at the same point. That's not what's happening. So no. Line Z intersects plane S at point C. Okay. So they're talking about plane S, which again is this plane over here. Picture this like it's a vertical sheet of glass, like a window. Alright, that's plane S. And then we have line Z crossing or intersecting that plane. So let's see, where is line Z? So here's line Z down here. Okay, so yeah, so it looks like line Z comes along and boom, hits the window, and the dotted line means that it's hidden. It's on the it's behind the glass. And then here it's got to the edge of the glass, and then that's why you can see it again. Alright, it's like when you have a heart and you want to show that you had an arrow through your heart. So the arrow goes like this. Boom! Okay, but then you can't see it for a while, and then the arrow comes out the other side. That's what's happening here. So yeah, this line is intersecting the plane at point C. So that's true. Alright, plane R and T intersect at line Y. Alright, so here's plane R, is this plane over here. Wow. Okay, and here is plane T, the one that's sort of horizontal looking. Alright, so that's plane R and plane T. Now, where do they intersect? They intersect, see this line that's going right across where the two planes appear to touch. Alright, so this is the crease between the two planes, like where the two windows cross each other. And this is line Y. So yes, the two planes intersect at line Y. So that is true. Okay, so there you go. Let's keep going. Triangle QRS is transformed as shown. Which rule describes the transformation? Now these are all rotations. Alright, I see this R. Alright, that means a rotation around the origin. And all that changes is the degrees. So, time for some notes. Where are my rules? Okay, these are the rules for rotation around the origin. Let me slide this over a little bit. So you should right now copy this down. Alright, I'm going to clip it so I can have it. Yes, these are the rules of rotation. Write this down on a little piece of paper and keep it next to you when you're taking the test or any review. So that we can recognize which rule is being applied, let's pick a point and follow it. For example, point S is a fine one to use. Point S starts off at the coordinates 4, 1. 4, 1. And then, of course, it becomes S prime. S prime is down here. What are the coordinates of this point? Well, it's over 1 and down 4. So that's 1, negative 4. 1, negative 4. So the question is, which one of these rules happened? Well, let's see. If this is X and this is Y, let's see what happened. First of all, did they switch places? 4, 1, 1, 4. Yeah, they switched places. Okay, so the Y came here and the X came there. Now, did anything change signs? Did the 4 change signs? Yes, it did. The 4 became a negative 4. So the X value changes signs. So the X becomes negative X. Did the Y change signs? 1 stayed 1. So no, the Y stays Y. So this right here is the rule that just happened. Now, which one of these did I just draw? See, Y, negative X. So that's this bottom one. Okay, so that means we're talking about a rotation of 270 degrees. So this should be the answer right there. Kabam! Alright, use your notes. Very important. Alright, which diagram has all the correct lines of reflectional symmetry for the rectangle? So a good way to picture this is imagine folding this rectangle along these lines. If these dotted lines are really symmetry lines, if you fold the rectangle, it should match perfectly. Now, focus on the bottom half of this rectangle. Imagine that I'm going to fold this up. Okay, I'm going to fold this up across this line, and I want to see if these are going to match perfectly. And I hope you can see that the answer is no. If I were to fold this directly across this line, this pink shows you where it would land. And you could try this at home if you wanted to. Just take any rectangular sheet of paper and try to fold it along the diagonal. See if the corners touch. You're going to find out that the corners do not touch. If this were a square, they would, but a rectangle, they don't. So this is not a line of symmetry. And of course, the same thing would happen if we folded across the other line as well. Again, it would not match. So these are not reflectional symmetry lines for this rectangle. Alright, so forget about that. That's not the right answer. Now, what about these lines? Alright, focus on the right-hand side of this rectangle. Now imagine that I folded this over this dotted line. If I folded the rectangle along this vertical line, would it match? Boom! If I folded it over, it would just land here perfectly. Alright, and again, you could do this at home. If you take a rectangle and fold it along a line that's right across the middle, it will match perfectly. Hot dog and hamburger. If you have no idea why I said hot dog and hamburger, don't worry about it. It's something that they teach some kids in elementary school about folding sheets of paper. Alright, this would have been called folding the paper hamburger. Anyway, now let's fold it hot dog. Focus on the top half of this. If I were to take this half of the paper and fold it down over the dotted line, is it going to match perfectly? It sure does. It's going to match exactly perfectly. That means that both of these are symmetry lines, reflectional symmetry lines. Alright, so this one is definitely not going to be the answer because it includes those diagonal lines that we already know are not reflectional symmetry lines. So far, it looks like this one's going to be the answer. These are definitely not anybody's symmetry lines. If we were to fold the picture along these lines, nothing would match at all. So this is definitely not it. So that means this one should be the answer right here. Let's reveal. And there you go. That's why this one is checked off. Okay, next problem. I see the R's. I see I've got rotations happening. So I went ahead and took out my rules, which you should have written down on a little piece of paper nearby. So, which rule describes the transformation shown? Again, a good thing to do would be just to pick a point and see what happened to it. So for example, let's see, what would be a good one? Let's do point R. Alright, so here's point R. It has the coordinates -3, comma 1, because it's left 3, up 1. So -3, comma 1. Now let's find R prime, which is right here. That has the coordinates -1, comma -3. It's left 1 and down 3. So -1, comma -3. Alright, so let's put that together. So we had -3, comma 1, and that became -1, comma -3. Now let's turn that into a rule. So we had X and Y. Now, did they switch around? 3, 1, 1, 3. So yeah, they switched around. So I'm going to have Y and X. Now, did anything change signs? I have -3, -3. So they did not change signs. So my X and my X should not be changing. But look at the Y's. Alright, the 1 became a -1. So the Y changed signs. So this Y is going to become a -Y. Alright, so this is the rule. So now let's match it. -YX. Alright, that's this one right here. Alright, that is a 90-degree rotation. So this should be the answer. And there you go. Okay, this is a little different. Alright, we have this little proof shown here. And we're given some information, and then they're proving that EG is equal to AB plus FG. So that's all well and good. This question, though, is actually a pretty simple question. They're just talking about what part of the proof is step 4. And so that's actually very simple because it comes down to 3 really basic things. In a proof, it has 3 main parts to it, which seem to be broken down right here. Alright, we have the given, and then we have the argument, and then we have the conclusion. Alright, it's kind of like the beginning, the middle, and the end. So obviously step 4 is part of the argument. Alright, it's not the given, which is obvious, and it's not the conclusion, which is going to be at the very end. It's always the conclusion is always the thing that you were trying to prove. Alright, so this is going to be the conclusion. So that just leaves the argument, the part in the middle. Let's check it out. I said let's check it out. I'm trying to delete this and it's not going away. Okay, that's not important. Maybe, what if I move it? Okay, yeah, there you go. It's part of the argument. Alright, let's move on. Cedric applied this rule. So what we are looking at is a composition of transformations. Okay, there are two transformations happening. And so hold on, let me just get my pen. Alright, so we have this transformation right here. Alright, this little r sub m means a reflection over line m. And then we have this transformation over here, which of course is a rotation of 90 degrees. Didn't really need to capture all that. So we have a rotation of 90 degrees around point P. Okay, now here's something very important. The order matters. The one on the right actually happens first, and the one on the left actually happens second. Okay, so first we have this rotation around point P of 90 degrees. Okay, and then second we have a reflection over line M. Okay, now what are they actually asking us? Cedric applied the rule. What mistakes did he make? Let's analyze. Now look at the primes to help you see what order Cedric used. So see how this shape on the top has no primes. It's just W, X, Y, Z. So that means this is the original figure. And then down below it has X prime and W prime. So that means this is the second figure. And then way down here we have the double primes. So that means this is the third figure. So that means what Cedric did was first, maybe I'll put this up on the top here, first he did a reflection over line M. Okay, that's what he did first. He did this reflection. And then, second, he did the rotation around point P. Okay, second, he did this rotation. Okay, now, when he did this rotation, how many degrees rotation is this? Can you see that the figure is turned completely backwards? Okay, that is actually a 180 degree rotation. It's completely upside down. A 90 degree rotation would have looked like this if it just turned sideways. Alright, that would have been a 90 degree rotation. So he turned it and turned it some more, all the way backwards 180 degrees. So right there I see he made two mistakes. First of all, he did the wrong order. He was supposed to do the rotation first and the reflection second. He did the reflection first and the rotation second. Also, he did a 180 degree rotation when the rule said he was supposed to do a 90 degree rotation. So let's look for the statement that mentions both of those two mistakes. Let's see. He applied the reflection to the pre-image first. Okay, yeah, that was definitely a mistake. That was one of the mistakes. Okay, he applied the rotation to the pre-image first. No, he didn't do that. He was supposed to do that. He changed the size of the figure instead of just applying rotation. No, same size. That's fine. He used point P as the center of rotation. Yeah, he did use point P, but there's a P right there. He's supposed to use point P, so that's fine. He used an incorrect angle of rotation around point P. Yeah, that's the other thing. He did 180 degrees, like I said. Should have been, he was supposed to do 90, so it should have been this pink type of an image. So these are the two mistakes he made. All right, there you go. Okay, which composition of transformation maps RSTUV to figure R double prime, S double prime, T double prime, U double prime, V double prime? Okay, so again, pay attention to the order of things. This is the original, this is the second picture, and then finally this is the third picture. Alright, so let's tell a little story. So let's say what happened first. And let's be careful to put that on the right hand side, because when you do two transformations, you're always supposed to put the first transformation on the right and the second transformation on the left. So how do you go from picture 1 to picture 2? Well, this is a reflection over line N. Can you see it? These are mirror images of each other over line N. So what we have here is a reflection over N. Alright, a reflection over, that's an R, a reflection over line N. That's what happened first. Okay, so that gets us from here to here. Now, how do we go from figure 2 to figure 3? Alright, it's taking a really long time for the word go to go away, so I'm going to have to stop pausing this. Now, hopefully you can see that this is some type of a rotation around point P. Alright, you can tell because of the way that it's turning. Instead of facing down, now it's facing to the side. A rotation is going to do that. Now be careful. It's tempting to imagine that it's rotating in this direction, all right? But that's clockwise. That would be like a negative 90 degree rotation. But none of these are negative. So remember, if I want to be positive, I have to go this direction around. All right? So I have to imagine how many times would I have to move this shape for it to, in this direction, counterclockwise, for it to land here. Okay, now this is a little tricky. All right, let's see. So if I move it once, come on. All right, so something about like this is what a 90 degree rotation would look like. So 90 degrees would be about in this position. All right, that's one turn counterclockwise. Now imagine that I kept going. All right, I'm going to make a new shape though. Okay, so if I rotated again another 90 degrees, all right, now I've gone a total of 180 degrees. All right, from this picture all the way to this picture. Now see how they're directly across from each other? That's 180 degrees. So one turn 90 degrees, another turn 180 degrees. But I'm still not there yet, so I need to do one more turn. Okay, which I'm going to try to show without pausing the video because it's starting to mess up. Alright, if I do one more turn, okay, now it matches. So this final turn is another 90 degrees, or a total of 270 degrees. 90, 180, 270 degrees. So we have a rotation around P of 270 degrees. So now let's just look at the choices. So again, first we had a reflection over line N, and then second we have a rotation of 270 degrees. So let's see, reflection over line N, followed by a translation. No, there was no translation. Let's try again. Reflection over line N, so far so good, followed by a 270 degree rotation around point P. That's the one. That's the one. So that should be the answer. Let's check it out. Okay. Just checking. I think this is the last question. Okay. Quentin tried to transform the triangle FGH according to this rule. Which best describes his attempt? Okay, so he was trying to do this rule. Alright, let me just write this down. So he was trying to do the rule XY, and he wanted it to become negative Y X. Now let's pick a point and see how we did. Let's see, I am liking point F today. Alright, point F starts off at 3, 2. 3, 2. So that would be like my X and my Y. Now, look at F prime. That is the point -2, 3. Alright, because it's left 2 up 3. Alright, so it went to -2, 3. Now, he was trying to do this green rule. Now, let's make a rule showing what he actually did and see if he was right. Okay, so let's make a blue rule showing what he actually did. Alright, so 3 and 2, that's like my X and my Y. First of all, did they switch places? Yes, 3, 2, 2, 3. That means the X and Y are going to switch places. So I'm going to have a Y and then an X. Now, which thing changed signs? Did the X change signs? Nope, 3 stayed 3. Did the Y change signs? Yes, the 2 became a -2. So the Y should become a -Y. Okay, now compare the green rule and the blue rule. He did it correctly. So that means the top one should be it. Alright, he did it right. Alright, and there you go. Okay, I hope this review has been helpful. Go give it a try on your own, and good luck.